Hello everyone, I hope you all are doing well. So let's start our project now where we will try to do the predictive analysis on this diabetic data set that we have. So I'm using here Google Colab platform, and as I said you in the last part of the project series also when we are doing the house price prediction, that you can use any of your platform. You can use Jupyter Notebook as well. You can use Visual Studio as well to write a code. I personally prefer Google Colab. The only reason is that, first of all, we are not dependent on the local environment. If anyone is having a bad configured system or it's a very small RAM storage system, it might be the case that when we will be dealing with a huge amount of data, your system starts hanging out. So, in order to avoid such kind of issues, I'm from scratch itself using the Collab environment where we have the access of free GPUs as well. And if in future requirement persists, we can take a pro subscription and work upon that, right? So let's try to start our project now, where you can see we will be having this empty file for now. What we will do, the very first task is I will try to load this data. And in this video, we will see the complete process of how we should understand the given data set. We will try to get the analysis of that. And then in the upcoming part of the video, we will start our major task of EDA, exploratory data analysis. So let's get started and we will try to load the data. Now there are multiple ways to load the data. What we can do is we can upload it or we can connect our Google Drive with this Colab so that we will be able to work with that. For now, what I'm doing is I'm trying to upload my data set. So here you can see I will be having a data of diabetes, which we will use in order to do the logistic regression task. So data is loaded for now. And what I will do is I'll just try to copy the path. Now, in order to work with the complete end-to-end project, we need to have 4 important packages installed within this library, this particular platform. And the good thing about Google Colab is that we don't need to do the installation. It's by default installed. We just have to import it. So what we can do is we can import the very first package which is required is pandas. Second one is numpy. Third one is matplotlib.pyplot as plt. And we will try to import cbon also as SNS. So that's the very first step. Then only we will be able to create a data frame, can make the plots, work with numbers. So all these 4 packages are something which is very, very important to import so that we can start our project. So the very first step which we have done is import of all the required libraries or packages. In future, if we require more, we will do the import at that point of time itself. But this is the preliminary, I would say, which is required. Okay, let's run this. Now, once it is running fine, the second task is to create a data frame so that we will be able to understand the data pretty well. First, what we will do, we will create a data frame. So let's create that. I hope everyone is aware that how can we create data, or you can write data frame also. Data frame is equals to pd dot read underscore CSV, because I think diabetes, if you can see, it's a CSV file. Now we can mention the path where our file is available, right? It's .csv extension. Can you see? That's why the function name will be read underscore CSV. Depending upon what kind of format of file you have, you will change your function, right? And now I want to display the majorly first 5 records available in this particular file so that I can able to understand that how this data looks like, right? So let's run this code. Now we can see, okay, we will be having few features available with us like pregnancies, glucose, BP, skin thickness, insulin, BMI, diabetes predictive function, age, and the last one is outcome. As you can see very clearly, the last particular column that we have, which is the outcome, contains the values are as either 0 or 1, which clearly indicates that it's a classification task. Because I hope you remember when we started discussing about the logistic regression algorithm, I told you what is the meaning of classification task and why we are using logistic regression algorithm in that specific task itself. right? So here we will be having either the values as 1 or 0. Okay. Now, if let's say I just want to understand only the columns per se, what are the columns or the features that I have? So I do have a function called as dataframe.columns, which basically gives me the idea or a list of the features that we have. And specifically, you can see in total, I think we will be having 8 features: 1, 2, 3, 4, 5, 6, 7, 8. And the last one is obviously a target value. So I am not considering this as a feature. It's a final outcome or a target which we want to predict, or which we want our model to give as an outcome, ki whether the patient is diabetic one or it's not a diabetic one, right? So that's fine, makes sense. Now let's try to understand ki what is the data type of each and every data feature that we have, so that we will be able to understand that is there any further important thing which is required on top of doing a EDA task. So what we can do is we can try to check the data type of each and every column that we have. So we can say D types, and once we run this, you will be able to understand that pregnancies, glucose, BP, skin thickness, insulin, age and outcome belongs to an integer type, whereas BMI and diabetes predictive function belongs to a float type. So this is the structure of all the types of data that we have with respect to the features available in our data set. In the next part, what we will do is we will try to understand that, is there any missing value available in our data or not, so that we will be ready ahead ki whether we will require a data imputation or not with the help of this understanding part of the data. So what we can do is we can just check the missing values in a given data set. So what we can do is we can say data frame dot is null and dot sum function. If you will apply, you will be able to get the summation of missing values if it is available. And you can see that, okay, the missing values are not available in a given data. That's a good thing. But let's try to examine this data in a more detail. So what I will do is, instead of printing this only top 5 records, maybe I will manually type a number, maybe 20, and let's try to print the top 20 records available in this data set. And let's try to examine this in a great detail, in a great observant mindset. So what you will be able to observe here, we will be having available 8 features and the final as a target, as an outcome. The only thing which is quite suspicious in this data, which I think, although we are not doctors, but at least this much we can understand, ki BP, if you can see very clearly, belongs to 0 at some point of time, for which the predictions are also 0. Or the actual, not predictions, the actual data contains the result as an outcome as in 0, means the patient is not diabetic. But can you imagine any patient, any person, who is having a BP value as 0, or who is having a skin thickness value as 0, insulin value as 0? Does that make sense to you? A person who is right, who is currently living, having their, doing their own work, is it possible? We know we are not doctors, but still we can understand this much part. So what this particular thing indicates to me, that there exist so many zeros which doesn't make sense. I am highlighting, right? All these zeros, wherever you can see in the features, although it is not a missing value, it's not a null value, but still zeros are there, which is a problem in case of this particular project to us. So obviously, when we will jump towards the next video, we will try to do the data imputation part, but not with the null values, but with the zeros, which is available in each and every feature that we have. Now, let's try to see the shape of this data as well. So one problem which we have observed while understanding this data set is that we need to do the data imputation of zeros in every feature, and we will discuss the mathematics behind that. So with respect to this part, we will try to focus on our upcoming session, right? So I just want to add this point in a bullet point so that it is understandable. and makes more sense to everyone. Second thing is, we want to see the size of this data. What is the size of the data set that we have? Basically, how many rows are there, how many columns are there. So for that, I hope everyone knows we have a function called as shape. So what we can do is we can say data frame dot shape. It will provide us that how many number of rows we have. So in total, we will be having 768 number of rows and 9 number of columns, in which you know that the last column is not a part of a feature set, it's a target column available to us. And that's the reason what we have observed in terms of understanding this data, that basically we have a target column which is available in this given data set by the name of outcome, which is either 0 or 1. So it indicates that it is a binary classification task. It is a binary classification task. Second important thing that we have understood here is that we will be having in total how many number of record size is there? Number of records that we have is 768. So whatever be the things that we will achieve in this particular data, we will have to work upon on this 768 number of record size only. So we can say it's a small data, right? It's not that much big data that we have, but yeah, we need to understand how we can apply a logistic regression algorithm on top of this. Now, why logistic regression? One thing is, you can see here it's a target column is available, which indicates, so I'm writing in the second point this thing and I'm removing this point here. So as the target column is available in the data set, that's the reason we can say it's a part of a supervised machine learning algorithm. Can we say? That's why it's a part of a supervised machine learning algorithm. Because we all know that whenever a target data is available, that is where we will say that, okay, it's a part of a supervised one. If the target data is not available, then obviously we need to think about unsupervised algorithms that we have. But for now, we have only discussed about supervised only. And that too, we have discussed only 2 algorithms till so far, linear and logistic. So this is the use case of a logistic regression. So I hope that this video gives you a great idea about the data which we will be working forward in the upcoming video. So please make sure I will try to provide this data set with you in the attached dashboard itself, so that you will be able to access this data. And whatever steps I have performed here in order to understand the data for now, I hope these steps is particularly clear to everyone. In the upcoming part of the video, you will observe, we will try to discuss about the EDA process now. That how we can do exploratory data analysis, how we will try to get the filtered quality data in this particular data set, so that we will be able to achieve a better accuracy, better prediction in a given model. With this, bye-bye everyone, and I'll see you all in the upcoming video where we will start our EDA process. And that is one of the most important video in the entire project part.